2.5 is finding the point of intersection. It starts equations and inequalities. The introduction, in problem 2.3, you used graphs and tables to find when the cost of two different plans for buying t-shirts were equal. I will remind you that the graph had t-shirts along the bottom and how much you paid for them along the side. There was a company called Mighty T that did not charge a deposit and charged $4.50 per t-shirt, and so it went up pretty steeply because of the $4.50 price. Then you had the company that charged $49 as a deposit and then $1 for every t-shirt, and that was no shrink tee. Now remember, as we were working through that problem, we found their point of intersection to be at 14 t-shirts. They both ended up being $63 at 14 t-shirts. So in going over that lesson, we talked about how it was cheaper to buy from Mighty Tees up until you got to 14 t-shirts. Okay, so we had that discussion that this is the y-axis and this is the x-axis, and these lines that run vertically are y coordinates. So at this point where they meet, that is called the y-intercept. And that's what we're talking about when we talk about the point of intersection. We had it written as an ordered pair, that at 14 t-shirts, going over to 14 and up to 63 is where we would find that point of intersection. So we were able to see it on the graph. We looked at two different equations that day. We looked at Mighty T when they had a $49 deposit, they didn't have a deposit at Mighty T. It was just $4.50 per t-shirt, but yet at No Shrink they had the $49 deposit plus $1 per t-shirt. So we looked at the equations. We looked at the equations that created the table, and we found at 14 t-shirts they were the same at $63 because we did this triple table of the number of t-shirts, what they would be at Mighty's and what they would be at No Shrink, and found this point here to be the y-intercept. So this is just a quick reminder of what we did that day. And since then, we have learned to balance out some equations by using the pouch and coin model, which is the same as the hands-on algebra kit. And it is also being used in tying that information in Investigation 3 into this one lesson today. So look at your paper. It is a problem much similar to the two t-shirt problem, except this is a bakery. At Fabulous Fabian's Bakery, the expenses to make N cakes per month is given by the equation. These are the expenses $825 plus 325 times N. Expenses are what a company pays out. They don't get to keep that. The income for selling N number of cakes is 820 N. And this is the money they get to keep that comes in. I'm not saying they're going to keep it because they may use it to pay out, but this is money that comes in. So you have expenses and income. A1. In the equation for income and expenses, what information do the y-intercepts give you? Now, they have a grid or a graph they've already done for you. They've got a line that starts at 0 and goes up. And then they've got a line that starts around 825 and goes up. And then there's a place where they meet. This is the number of cakes at the bottom, and this is the amount of money that is made. If this line starts at 825, it is the expenses. This top line is the line that they pay out with. This is the line for expenses. So I would go ahead and label an E there on that graph. So I would know that this line represents the things that they pay out. Then, that means that the one that starts at 0, remember y is equal to mx plus b. Y is equal to mx. They have no b, so it starts at 0 down here. So this is going to be your income line for that graph. So knowing what you're looking at and what you're supposed to be reading definitely helps. So number 1, what information does this y-intercept give? That's what that question is asking. What does that point on the graph tell me? That means, just like the t-shirts when they both met at $63, this is when your income and your expenses are equal. It's where you break even at. When you're spending or bringing in and paying out the same amount, where you break even at 0. When you're bringing in just as much as you're paying out, and it would equal out at 0, that's where you break even. So that's what A is asking. The y-intercept here tells how many cakes needed, because down here that's the number of cakes. How many cakes needed? To break even. When you're bringing in enough for what you've got to pay out, where you will equal 0. Now, you'll notice on your graph, here's 100 cakes, here's 150, and here's 200 cakes. You already can tell just by looking at the graph that it's going to take more than 150 cakes to break even, but not 200 cakes to break even. So we still have some work to do to answer some questions, but we can still go ahead and predict based on what we can see on our graph. Now, number 2 asks, what do the coefficients of N represent? When we're looking at the coefficient of N in expenses, our coefficient is $3.25. Remember, the coefficient is the number that's in front of your variable. If this money we're paying out, and this means cakes, that's how much money it takes to make one cake. So that's what it means. How much money to make one cake. So that's what the coefficient in the expenses equation represents. Now we're fixing to look at the coefficient in the income equation. It's 8.20 N. What do you think the coefficient in the income would mean? If that's money I'm bringing in, then what should this price mean? Dinar? This would be the money that comes out of your budget for each cake. If it costs me this much to make one, then what should this be? How much I'm going to sell it for. So if it costs me $3.25 to make a cake, then $8.20 is going to be how much I sell that cake for, to make a profit. I don't want to sell it for what I have in it, or I'm not going to make any money. I've got to charge more for what I sell it for than what it costs me to make it if I want to make any money. So the coefficient in the income is how much money one cake sells for. Can I find how much profit I'm going to make on one cake by the information that I already know? If it costs $8.20 to buy one, and it only costs $3.25 to make it, then I'm making $4.95 for each cake I sell as profit. This is money that I keep, that I make. If it costs that much to make one and I'm selling it for that much, I'm actually making that much money off of each cake. So this answered A1 and A2 with a little bit of extra information given, because there's going to be questions asked about that. Now, B goes in a little different direction and says, okay, Fabian is selling 100 cakes in January. So I know I can go here on the graph where it says number of cakes, and I can get some information from that. I can go up and I can see on the income line how much he's bringing in January for 100 cakes. And I can still go up 100 cakes and see how much it costed him to make it, to make those 100. So there is that difference right here in what it cost him to make it and what he's going to sell them for. They've already done that math for you. It says that there's a $330 difference there. So that's just looking forward into what it's going to take to determine the answers to Part B. Any questions so far? Okay, then let's look at B. I'm going to leave up the graph because we will be referring back to it. What is his expenses and his income in January? That's what number 1 says. Now, you can do this 2 ways. You can look at the graph and try to figure it out, but you'll notice when you come over here, it doesn't fall straight on the line. It's between lines. So you have to do some guessing or some estimating at that point. But they've also given me the expense equation, and I have to solve this equation for 100 cakes. So all I have to do is plug 100 into the number of cakes, and then it will let me know what the expense is, what it's going to cost to make those 100 cakes. Now I'm assuming that this $825 is like the rent for the cake shop, the light bill, the gas bill, the water bill, any of the utilities that there's going to be. So I'm pretty sure that's how much it costs for the facility. And then it costs this much per cake for 100 cakes. So solving this, that's 825 plus 325, which gives us $1,150. So that's where this line comes here. That's where it falls here, is 1,150. At 100 cakes, this is the expenses, 1,150. 150. Now the income is the same thing. They've given me the formula for the income or the equation. It's $8.20 per cake for 100 cakes. I just plug 100 into N, and that gives me $820. So this answers the question for what is his expenses and what is his income for the month of January. Number 2, what is his profit? Did he make a profit? He owes this much. He's only bringing in this much. Profit would be if his income went above this. Did it go above it? No. Then he did not make a profit. So he has no profit. He's actually $330 in the hole. He's minus $330. I kind of knew that, though, by looking at my chart, at my graph. We already said that this is where he breaks even, and it's going to be well above 100 cakes. We looked at what we were given by the graph and kind of done some predicting as to where things were going to fall, and said if the y-intercept is when the income and expenses are equal to each other, then it's going to be before 100, and he won't make a profit until he passes that point. So it says describe how you found the answer. Now you could have looked here on your graph and seen that he did not make a profit, that his income was still less than his expenses by 330, because they did that math for you and even wrote it in the graph. Or you could have done it just like we did here and plugged it into those equations for expenses and income, which will give you exact numbers, and you won't have to guess if you fall between an interval on a scale that might be 50 points apart or 70 points apart. If you use the equations, you're going to get exact numbers. You won't have to guess where they might fall. Number 3, Kevin drew the graph that you're looking at on your paper, and it said explain how he could use this graph to determine Fabian's profit. And again, we just talked about it. You look at these two, you go to 100 cakes, and you would subtract the income and expenses for 100 cakes on that y-axis. And that's going to give you that $330 deficit. He's still in the hole and isn't making a profit. He has to make $330 more just to break even. And then if he does more after that, then he will start making a profit. Any questions about B? Yes. It was the same thing here. You have to go to 100 cakes on the graph. Go up and find where the income is for 100 cakes, where the expenses is for 100 cakes, and subtract the two. And they've already done that for you at $330. C wants you to write an equation that represents the profit for selling in cakes and describe how you can use this equation to find the profit. Now we just said if you take your expenses and subtract out your income, that gives you your profit. Or if you take what comes in and subtract what you've got going out, that's going to give you the profit. So this is going to be the income. He's making $8.20 per cake. So when you take that and subtract out what he has to pay out, which is $8.25 plus $3.25 in, this is how we find out profit. We just took the equation for what's coming in, subtract what's going out, and what's left is the profit. If it's a positive number, then he has made a profit. If it's a negative number, then he has not yet made a profit. It's just taking the two equations that they gave you at the very beginning and subtracting them from each other. Andrew? No. Number 2 says that Fabian uses the equation that his profits are $4.95 for each cake, subtracting out the $8.25 that he has for his expenses. Now what it says here is, does this equation make sense to you? Didn't we find the difference in this and this a while ago? We actually subtracted them out, and what were we given? $4.95. And then subtract what's left. Shouldn't this give you the same thing that this gave you? So it should make sense to you that this is the profit for every cake, but he still has to take out what doesn't deal with the cake. Any questions about C? Turn over to D. The break-even point is when expenses equal your income. Again, this is the break-even point, that y-intercept. It's when your expenses equal your income.